Okay, so right now everything is visible to you. Okay, should we move ahead? Okay, so okay, till now we've understood that if I'm saying that the function is non-analytic at a point, let's say z naught, then I cannot expand my function in form of a Taylor series above z equal to z naught, and I can expand no doubt in terms of something called as Laurent series. Okay, are you getting my point?
Yes, sir.
Okay, so there are questions that have been asked in the examination also. Let us take some help from them also, so that you should be able to understand how to proceed. So, question that appeared in your exam only. So this appeared in net December 2014, and this is a simple question to ask. And just understand the fact that written is Laurent series, even if you're not able to know that how to go about these formulas, if certain function like e raised to power z is there, you can do the same Taylor series representation. Don't worry about it. Okay, so Laurent series expansion of the function let given was fz is equal to e power z plus e power 1 upon z about z equal to 0 is option number 1 that was given was summation z raised to power n upon n factorial for all mod z less than infinite. Option B was summation n equal to 0 to infinite z raised to power n plus 1 upon z raised to power n and whole multiplied with 1 upon n factorial only for mod z less than 1 and mod z greater than 0. Option number C was summation n equal to 0 to infinite z raised to power n plus 1 upon z raised to power n times 1 over n factorial for all mod z less than infinity and greater than 0. And option D was summation n equals to minus infinite to plus infinite z raised to power n upon n factorial only if mod z is less than 1. So how to approach such problem? This is an easy question.
C.
C, right? So this would be C. So for example, the first part is e raised to power z, and you can clearly see this is 1 plus z square upon 2 factorial plus z cube by 3 factorial. Okay, and z raised to power n upon n factorial. You can write it in an infinite series. Okay, and the second term is obviously singular at z equal to 0. It is singular at z equal to 0. So what you are going to do, you're going to make an exception to it. You'll say that I'm not going to take this particular point. So I'll exclude this particular point, that is z equal to 0. And all over, otherwise, it will be fine, because e raised to power z says you, okay, so if I write it in this, here I'm writing. So what does e raised to power z says to you? It says that I'm an entire function. I'm an entire function. I can be completely written in a form of power series for all mod z less than infinity. But what does 1 upon e power z says? 1 upon e power z says that, okay, I would say that I am completely agreeing on this particular zone. That is 1 upon z mod. Instead of 1 upon z, you just take mod w. But what does it mean? It says that I would be completely analytic for all mod z greater than 0. What does it imply? It implies that distance from 0 should be greater than 0. That is, there should be some distance from 0. That is, exactly at 0, it will be not defined, because exactly at 0, there is an essential singularity. So beyond that, it is fine. So what would be the radius of convergence? The radius of convergence would be mod z greater than 0 and less than infinity. That is, you would have a punctured disk. Punctured disk at origin. Okay, so at exactly at origin, you will not have any, you will have a singularity. Otherwise, for all these points, that is for all points mod z less than infinity and mod z greater than 0, you can expand both of these terms in a power series. So what will be the power series here? 1 plus z plus 1 upon 2 factorial 1 over z square and dash 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 1 upon n factorial 1 over z raised to power n dash dash dash. So what you can write, the function can be written as summation n raised to power 0 to infinity. This is z raised to power n upon n. This is plus 1 upon n factorial plus into 1 upon z raised to power. And this is your function's series representation and valid in the region mod z less than infinity greater than 0. That is, it is valid in a punctured disk at origin. So at origin you have a puncture. Puncture means you cannot include the origin. And accepting origin, you can write this particular function in a power series of this fashion. So answer would be C. Are you getting my point? समझ में आया बच्चों को? कहाँ गए वो दोनों बच्चे, कहाँ गए?
हाँ भैया।
ओके
यस सर। सर एक्सपोनेंशियल और साइन और कॉस इन सब के अलावा भी कोई एंटायर फंक्शंस और कौन से होते हैं?
इसके अलावा और कौन कौन से होते हैं, मतलब किन किन की सीरीज लिख सकते हो तुम, राइट? So you can write a power series about x equal to 0 for ln 1 plus x. You can write a binomial series. You can do for 10z also. No? So कुछ कुछ तुम्हें books में मिल जाएंगे. You just search in the book like H.K. Das or somewhere. You'll find all these series representations. So that would be easier thing to do in exam. Otherwise, you will have to write in the, लिख तुम सब के सकते हो, मतलब तुम्हें अगर टेलर सीरीज लिखनी आती है, डेरिवेटिव्स लेने आते हैं, तो you can do for everything, but you cannot remember each one of them. समझे मेरी बात? मतलब टेलर सीरीज लिखने के लिए
सर
क्या
वो
करना है?
सारे एंटायर फंक्शन थोड़ी ना होंगे फिर।
नहीं,
इनकी भी हम
एंटायर फंक्शन वुड बी e raised to power z, एंटायर फंक्शन वुड बी sin z, एंटायर फंक्शन वुड बी
cos
cos z. इतने मुझे पता है. इसके बाद सारे
जी
फंक्शन, लेट्स से sin इनवर्स z मल्टी वैल्यूड फंक्शन हो जाता है, लोगरिथमिक फंक्शन मल्टी वैल्यूड फंक्शन हो जाता है ना? तो ये बहुत सारे फंक्शन तो फिर मल्टी वैल्यूड हो जाएंगे. तो मोस्टली जो अभी तक हमें समझ में आ रहे हैं, अभी तक हमारी स्टडी के अंदर है, वो ज्यादातर e raised to power z, पॉलिनोमियल फंक्शंस एंड sin z एंड cosine z, रैशनल फंक्शंस जहां पे डिनोमिनेटर जीरो ना हो. Okay, so polynomial function is fine. It is analytic everywhere on the finite complex field also. Are you
ओके
getting?
सर। और यस सर। सर एंटायर फंक्शन कैसे पता लगाते हैं सर? मेरे आप रिकॉल करा देंगे, याद नहीं आ रहा।
एंटायर फंक्शन, लेट्स से अब तुम कह रहे हो कि e raised to power z एक एंटायर फंक्शन है कि नहीं, तो क्या करो, इसका पावर सीरीज रिप्रेजेंटेशन लिख लो. सबसे आसान तरीका तो ये भी हो सकता है, इसका पावर सीरीज रिप्रेजेंटेशन लिख लो और देखो इसका रेडियस ऑफ कन्वर्जेंस क्या है. सो लिमिट n टेंड्स टू इंफिनिटी, I think the an plus 1, so this will be an plus 1 upon an, and this is 1 over r. So 1 over r limit value would be 0. That implies r is equal to infinity. So it is completely convergent for all r equals to infinity. It implies what? It implies that this particular series would be convergent for all mod z less than infinity. So again, this is entire function. Similarly, sin z and cosine z would be an entire function because they can be written in the linear combination of e raised to power z and e raised to power minus, sorry, e raised to power iota z and e raised to power minus iota z. So कुछ कुछ चीजें तो ऐसे आ जाएंगी, कुछ कुछ चीजें फिर हमको याद करनी ही पड़ेंगी because again I'm saying this is a one semester course for mathematics people. A few things we'll have to accept right away. Let's say sin z cosine z are entire function. E की power z is an entire function. Any polynomial function is an entire function. Is an entire function. In fact, you will find that your constant function is also an entire function. But only point is that it is even the domain of holomorphy may also extend to z equal to infinity.
Yes.
Because it is even analytic at equal to infinity. Well, I will say. So all these things you'll have to accept right now because then it would be too difficult. मतलब हर चीज नहीं पढ़ पाएंगे. But yes, do understand the point that sin z, cosine z, e की power z, these are all analytic functions. These are all analytic functions for all mod z less than infinity. So these are entire functions, so to say. Okay, should I move ahead?
Yes, sir. Sir, and Laurent series cannot be written for all the functions, right?
Yeah, it can written for all the functions, provided you are writing it in the right domain. You are not including the singularity anymore.
Like if exponential e to power z,
Hmm.
there'll be no term of 1 upon z, no?
There would be no term of 1 upon z. So there, the Laurent series is actually equal to Taylor series because there is no such Laurent series for this. See, for Laurent
Okay.
series, you need to have this singular part. Some 1 upon z minus z naught part you have to have. Otherwise,
Right,
you'll not
sir.
say it in Laurent series. You would say that this is a Taylor series. So it
Like
is
it's a more generalized case.
you can say it is a more generalized thing because now you can exclude the singularity and you can write a convergent series in some annular region. So that particular series representations are called as Laurent series. For Taylor series, there is no such obligation to write it in an annular region. It would have some circle of convergence. I'm not saying it would be always mod z less than infinity, but there would be some circle of convergence. So Taylor series would require me to say that this is my domain of convergence. That is some circle of convergence about z equal to z naught. But what does a Laurent series would do? Laurent series would tell me, okay, I am convergent in some annular region because there is some term of this sort also. So I would not say that e raised to power z is expansion would be a Laurent series, but I'm just trying to make a point because e raised to power 1 upon z was added to it. So there is a singular part added to it. So the entire this entire thing representation would be then called as a Laurent series representation because you now have some singular term also. Yeah, some principal part. Are you getting my point till now?
Right, sir. I say got it, sir.
Okay, so let us move ahead and see how the classification of singularities can be done on the basis of the Laurent series. And that is very important for you in examination also, because at times that limit thing that I taught you 2 days back, you may not be able to always follow that up. Okay, so classification of singularities. So point number one, how to see what all are singularities. So you can clearly see that singularities would eventually depend upon the singular part or the principal part of the Laurent series expansion. So I already taught you that a Laurent series representation is of this fashion. So this is in this manner I can write. Okay, so this is the way that I can write a Laurent series, isn't it? So if my function is non-analytic at z equal to z naught, I can write my function in form of a Laurent series. This is my Laurent series. Yes or no? Okay, and this is something what is called as the principal part. So let us first move to something called as removable singularity. So what does removable singularity would mean? That it can be removed. It can be removed. So for example, the best case was sine z raised to power sine z raised divided by z. So what you would find that for principal part, for removal singularity, there would be no such principal part. Okay, for removal singularity, there will be no terms in the singular part. So no terms in the principal part. So for example, if I say that at z equal to 0, what sort of singularity does sine z over z have? So we saw earlier also that this is a removable singularity because at z equal to 0, limit z tends to 0, sine z upon z exists. That is equal to 1. So if I'm saying my function is singular at z equal to z naught and my limit z tends to z naught fz exists, then I would say that my function fz has a removable singularity at z equal to z. Yes or no? And either you go this way or I'm saying just expand this in a series form. So what will be series? Z minus z cube upon 3 factorial plus z raised to power 5 upon 5 factorial, so on and so forth, and divide by z. What you will get? You get, I think, 1 minus z square upon 2 factorial plus z ki power 4 upon 5 factorial, so on and so forth. So you do not have any principal part term. That is, you do not have any term whose powers are negative. The powers are positive. So it is completely regular. I told you also to say that it is not singularity in the most stricter sense. So clearly you can say that if there are no terms in the principal part of Laurent's expansion, Laurent series expansion, then you can say that at z equal to z naught, uh, the singularity is of removable type. Again, I'm repeating, if your function fz, Laurent series expansion, does not contain any principal part term about z equal to z naught, then z naught is said to be the removable singularity. Should I move ahead?
Yes, sir.
Okay. Now, what if I say that your series representation gives you such terms? An z minus z naught raised to power n, absolutely fine. I have no issues about it. But then it starts giving you some terms like this. And it may be possible that these terms may be zero, like coefficient may be zero. So now you have what is the singularity? The singularity is clearly z naught. You can see. Now, in such case, if you have m such points, like you have m such points, m such terms in the principal part. So you have m terms in the principal part. Then it implies that z equal to z naught is a pole of order n. It is a pole of order n. Okay. Are you getting my point till now? I would tell you an example. Let's say if I'm saying sin z divided by z raised to power 6, what would be the singularity? Clearly, z equal to 0 is a singularity. Now, what sort of singularity is this? So I would say this is a pole of order 5. Why I would say? Because limit z tends to 0, z minus 0 raised to power 5 into sin z divided by z raised to power 6 would give me limit z tends to 0, sin z upon z equals to 1. So what is the limit? Limit is clearly a non-zero scalar finite number. Non-zero finite scalar. Are you getting that point? And this was the order of your pole. Now, if you argue that no, since here z raised to power 6 was there, and why did you not multiply with z raised to power 6? Multiply with z raised to power 6. So z raised to power 6 gets cancelled with z raised to power 6, and the limit would come as 0. And in fact, if you take any other point, let's say lesser than 5 and greater than 7, greater than 6, you'll find that there would be somewhere infinity propping up, or there would be somewhere 0 propping. So the pole will be of order 5 for this case. Okay. Now, how to see this particular thing by the help of the Laurent series? So sin z upon z raised to power 6, how would you say? So you just write the series representation, z minus z cube upon 3 factorial plus z raised to power 5 by 5 factorial minus z raised to power 7 upon 7 factorial, and so on and so forth, divided by z raised to power 6. What you would get? You would get simply some 1 upon z raised to power 5. Then you will have minus 1 upon 3 factorial z square. You will have 1 upon 5 factorial 1 over z. And then you will have some regular terms. So there will be some regular terms. I'm not interested there. Now, there is a confusion. Most often, students ask that here you have only 3 terms. But understand my point, these are not 3 terms. There are terms in between as well, but the coefficients are 0. So just keep a track of this number. Just keep a track of this number, I'm saying. The highest, I will not say degree, but the exponent here. So just keep track of this number, because all these terms exist. Like if you say, here I do not have 1 upon z raised to power 4, you have 1 upon z raised to power 4. The only thing is that coefficient is 0. Okay, so overall, there are 5 terms. So this will be pole of order 5. So the principal part of your Laurent series expansion contains 4 terms. समझ में आ रहा, ऊपर से चला गया?
एक बार रिपीट करिए।
ओके, देखो मेरी बात सुनने की कोशिश करो। लोरेंट सीरीज में क्या करना है आपको? लेट्स से मैं कह रहा हूँ sin z अपॉन z की पावर 6, ठीक है? इसको लिखो z माइनस z क्यूब अपॉन 3 फैक्टोरियल z की पावर 5 by 5 फैक्टोरियल. You have to write minus z की पावर 7 upon 7 factorial. Then you have to write z की पावर 9 upon 9 factorial, and so on and so forth. Divided by z raised to power 6. अब हो क्या रहा है? इसको डिवाइड करो तो क्या आएगा? 1 upon z की पावर 5 minus 1 upon 3 factorial z की पावर 3, sorry. Then you have plus 1 upon 5 factorial 1 upon z. Then you have minus z upon 7 factorial. Then you have z cube upon 9 factorial. This is your principal part term. नहीं, ये तो हो गया तुम्हारा regular part. So I'm not interested here. This is your regular part, क्योंकि सारी powers कहाँ आ रही ऊपर, यहाँ देखो नीचे की तरफ आ रही है. Now there's a problem. People ask, most often I have found students asking me that there are only 3 terms in the principal part. And I always argue to them that there are 5 terms. Understand? There is a term in 1 upon z square. There is a term in 1 upon z ki power 4. The only point is that coefficient is 0. Okay, there is coefficient is 0. Therefore, you cannot see them here. Overall, always keep a focus on this particular power. The highest power that occurs in 1 over z, that would decide the order of the pool. So clearly see that I told you that if I was defining what is a pole of order m by writing a Laurent series expansion, what I was doing, I was writing a regular part. Then I had these parts, and I was saying if your principal part term contains m terms, so even if you, by counting, if you find that there are 3 terms, understand that there are terms between also, but their coefficient would be 0. Just keep a focus on this particular point. So the highest exponent that occurs over z minus z naught, 1 upon z minus z naught forms the order of the pole. Okay, so clearly sine z upon z raised to power 6 at z equal to 0, you are having a pole of order 5. So this is what I also told you from my limit analysis. That is from the basic definition of what we've done. Okay. And what if the principal part contains infinite number of terms? So what if the principal part of the Laurent series expansion contains infinite number of terms?
Essential singularity.
Then this would be an essential singularity. That would be an essential singularity. That would be an essential singularity. Let's say 1 upon z. Let's say sine 1 upon z. So all these series at z equal to 0 would contain some infinite powers in 1 by z. And since they contain infinite powers, so these are essential singularities. Okay, should I move ahead? Okay. So right now we are going to do a few questions, and then tomorrow also we are going to do a few questions, and then we'll finish it off, and we'll start with integration. Okay. So do a few more questions so that you are able to understand, able to follow what is this, because ये चीज समझ में आने लग गई तो फिर सब समझ में आने लग जाएगा, because integration में यही सब है. If you're not able to identify the right singularity, kind of singularity, then you will not be able to understand. Okay, so see, let us do a few more questions. So the first is, let's say if I'm telling you to expand a function that I'm giving to you. Okay, let's say this is your function. Let's say fz is equal to e raised to power 2z divided by z minus 1 ka whole cube. So you can clearly see that at z equal to 1, there is a singularity. So I want a Laurent series expansion for this particular function about z equal to 1. That is, my Laurent series will contain the terms of z minus 1. Okay, some regular terms and all those things. So this is how it is written. Expand this function fz in a Laurent series about point z equals to 1. So z equal to 1 clearly is a singularity. You can see that z equal to 1 is clearly singularity. So how would you go about this question? I'll tell you. You kya karo? Since e ki power z, you know, you can write a series representation for e ki power z. E ki power z, you can write a series representation. The only problem is this. So just do one thing. You write z minus 1 as some u. Any issues about it? And that would tell you that z is equals to 1 plus u. Any issues about it? If z can be written as 1 plus u, then your fz is equals to e raised to power 1 plus u. Sorry, 2 plus 2u, if I'm not wrong. 2 plus 2u. Sorry. ठीक है? Divided by u cube. कोई दिक्कत इसके अंदर? And you can write e square. This is e की power 2u upon u cube. है ना? ये function of u है, बाद में इसको z कर देंगे. This is e square. And what is e की power 2u? This is 1 plus 2u. Then this is 4u square upon 2 factorial. Then this is 8u cube upon 3 factorial. Then this is 16u की power 4 upon 4 factorial dash dash dash, and divided whole by this whole divided by u cube. Okay, and what it will give you? It will give you, I think, if I'm not wrong, it will give you e square will be there. It will give you 1 upon u cube. Then you will have 2 upon u square. Then you will have 2 upon u. Then you will have 8 upon 6 plus you will have 16 upon 24 u, and there will be some terms. So what is this? This is your regular part, isn't it? This is your regular part. And what is this? These terms are your singular part, isn't it? Or your principal part. अब मुझे इसको देख के बताओ, what is the pole? Is it a pole? U equal to 0 is a pole. अच्छा, एक काम करो, पहले z को, इसको suppose z में convert कर लेते हैं. And so function of z, that is your series, function e raised to power 2z upon z minus 1 का whole cube can be written in a power series, in a series form which contains some principal, which contains some regular part, इस तरीके से कुछ, and some principal part. मैंने अभी भी बोला था कि जब इस तरीके की सीरीज होती है जहां पर you have some regular part and you have some principal part, ये सीरीज क्या कहलाती है? लोरेंट सीरीज तो कहलाती है. देखो मैंने क्या किया, तुम्हें मैंने थोड़ा बाईपास कर दिया. वो इतना सारा वो देखा था, एक इंटीग्रेशन दे रखा था, वो सब नहीं करना है. यू जस्ट सी दिस. ये देखो, ये हो गया प्रिंसिपल पार्ट, ये हो गया तुम्हारा रेगुलर पार्ट. ये सीरीज क्या कहलाएगी? लोरेंट सीरीज तो कहलाएगी z इक्वल टू 1 के बोर्ड. सॉरी, इसको z माइनस, इसको लिखो z माइनस 1, इसको भी लिखो z, बचा हुआ था ही नहीं. ठीक है, ऐसा कुछ. आर यू गेटिंग माय पॉइंट? ये चीज समझ में आई? अब मुझे इसको देख के बताओ, व्हाट सॉर्ट ऑफ सिंगुलैरिटी वी हैव एट z इक्वल टू 1. z इक्वल टू 1 किस तरीके की सिंगुलैरिटी है?
Order 3.
It is a pole of order 3. Okay, बढ़े आगे. Okay. Okay. Now next is try to do this z minus 3 into sine of 1 upon z plus 2 at z equals to minus 2. So you can clearly see that z equal to minus 2 is a singularity. That you can see that z equal to minus 2 is a singularity, yes or no? Okay. Now I'm asking
Yes, sir.
that z equal to minus 2 is a singularity, and I have to write a Laurent series. I have to write a Laurent series about the singularity. How to do? About the singularity means the Laurent series would contain the term z plus 2. Okay. So how to go about it? So Laurent series will contain the term z plus 2. So a simple idea would be to write z plus 2 as u. Just write z plus 2 as u. So this particular term will become u minus 3, isn't it? And this will become, I think, sine 1 upon u. And what you can do, simply expand this. So life will be easy for you. U minus 3 into 1 plus 1 upon, I think, u minus u cube upon 3 factorial plus u raised power 5 by 5 factorial. Then you will have u raised to power 7 by, minus u raised to power 7 by 7 factorial, so on and so on. Okay. And this u minus 3, you can...
So u minus 5 1 first.
U minus, my mistake. U minus 5, sorry. U minus 5. Okay. So this is u minus 5 and you multiply with all these things. So what you would get, I think this is 1 upon u now. My mistake. 2 minute रुको यार, sorry.
Yes, sir, 1 upon u.
Sorry. एक मिनट मुझे दिमाग घास चढ़ने चला गया. 2 मिनट रुको. My mistake. ठीक है, सॉरी. तो मतलब समझ रहे हो, मतलब कोई जरूरी नहीं है वो इंटीग्रेशन जैसा दिख रहा था ना, वो करने की जरूरत नहीं है. जहां पे तुम कन्वीनियंटली निकाल सकते हो वहां निकाल दो, जहां नहीं निकाल सकते वहां भी सिखाऊंगा, डोंट वरी. बट अभी के लिए जो सिंपल एग्जांपल्स है वो करते हैं. ठीक है, जैसे कि तुम इसको पहले लिखना सीखो. तो क्या किया, z plus 2 को u लिखा, दिस विल बी u minus 5 एंड दिस विल बी, आई थिंक, sin 1 upon u. और एक काम करो, इसको लिखो u minus 5 और यहाँ पे क्या आएगा, 1 upon u minus 1 upon 3 factorial 1 upon u cube and plus 1 upon 5 factorial 1 upon u raised to power 5 और फिर आगे तो चलता ही जाएगा जो कुछ. ठीक है, और आप क्या कर सकते हैं, यू कैन सिंपली मल्टीप्लाई द एंटायर थिंग विद u minus 5. So what you will get 1 if you multiply with u, then you will get 1 upon 3 factorial 1 upon u square. Okay, then you will get 1 upon 5 factorial 1 upon u की power 4, then you will get minus 5 upon u, then you will get plus 5 upon 3 factorial 1 upon u cube, then you will get minus 5 upon 5 factorial 1 upon u की power 5. तो तुम देख सकते हो how many terms are there in the denominator. So that if you write again u in terms of z plus 2, so what you'll get 1 minus, नहीं माइनस नहीं, यहाँ देखो लीनियर पावर में minus 5 अपॉन u, तो u को लिख दो z plus 2. देन स्क्वायर में कौन सा है, आई थिंक ये रहा. देन पावर 3 में कैसा टर्म है देखो, आई थिंक कहाँ गया पावर 3 वाला टर्म, ये रहा ना 5 अपॉन 3 फैक्टोरियल. 5 अपॉन 3 फैक्टोरियल कितना होता है, आई थिंक 3 फैक्टोरियल होता है 6 ना, तो 5 अपॉन 6 ऐसे कुछ टर्म्स आते रहेंगे. ठीक है, आगे के टर्म्स देखते रहना तुम. इन फैक्ट यू विल फाइंड दैट देयर आर इनफिनिट नंबर्स ऑफ टर्म इन द इनफिनिट नंबर ऑफ टर्म्स इन द प्रिंसिपल पार्ट. दिख रहा है ये, देयर आर इनफिनिट नंबर ऑफ टर्म्स इन द प्रिंसिपल पार्ट. सो इफ देयर आर प्रिंसिपल पार्ट में इनफिनिट नंबर ऑफ टर्म्स, इट इंप्लाइज z इक्वल टू -2. क्या हो जाएगा बताओ, it will be an essential singularity. It will be an essential singularity. बढ़े आगे, yes or no? Now tell me what.
सर एक बार,
हाँ पूछो.
सर एक बार ऊपर करना थोड़ा सा.
हाँ हाँ सॉरी सॉरी, मैं गलती तो नहीं करती ना, मैंने जल्दीबाजी में देख लेना प्लीज. Actually, the as this time shows me less than 10, then I start panicking. वाली बात है.
सर 2 सीरीज आएंगी ना सर इसमें?
हाँ 2 सीरीज आएंगे बेटा. मैंने मल्टीप्लाई कर लिया, u से एक बार मल्टीप्लाई कर लिया, 5 से मल्टीप्लाई कर लिया.
5. ठीक है सर,
कर लिया,
कंटिन्यू.
कर लिया मैंने. और फिर इसको तुम अगर थोड़ा खोल के देखोगे तो you'll get थोड़ा देख लेना. आई डोंट थिंक कैलकुलेशन हो सकता है, कुछ कांस्टेंट्स में इशू हो सकते हैं, बट ओवरऑल द सीरीज विल बी ऑफ दिस फॉर्म. ठीक
भैया
है,
पर एक मिनट सुनो,
हाँ बोलो.
ये है ना, मतलब आई may sound stupid पर आप सुनो, जैसे ना bn upon z minus z naught, तो ये प्रिंसिपल पार्ट है. ओ ओके ओके सॉरी आई गॉट इट. ठीक है, सॉरी सॉरी मेरी मिस्टेक.
चले बढ़े आगे. चलो देखो, मेरी बात समझने की कोशिश करो, एक क्वेश्चन और करो. जब तक एक क्वेश्चन, और प्लीज क्वेश्चन करो, नहीं तो देखो मैं कितने करा सकता हूँ, मैं हो सकता है एक सेशन और दे दूं. इसके बियॉन्ड तो तुम्हें प्रैक्टिस करनी पड़ेगी ना, क्योंकि बिना उसके काम नहीं बनेगा. मतलब कॉम्प्लेक्स, और मैंने इसलिए कॉम्प्लेक्स पहले लिया बिकॉज देखो इसका थोड़ा सा इंटरवेंशन फिजिक्स में है, नो डाउट. स्कैटरिंग थ्योरी में है, कॉन्फॉर्मल मैपिंग की तो इलेक्ट्रोस्टैटिक या फ्लूइड डायनेमिक्स में भी है. बट दे आर टू डिस्टेंट टॉपिक्स फॉर योर नेट एग्जामिनेशन राइट नाउ. सो राइट अवे हो सकता है मैं ना पढ़ाऊं, हो सकता है मैं फिजिक्स के अंदर तुम्हें बताता जाऊं कि कैसे कॉम्प्लेक्स एनालिसिस लग रहा है. बट ओवरऑल दिस पर्टिकुलर चैप्टर को तुम्हें थोड़ा मैथमेटिकली पढ़ के इसको एक तरफ डिस्कार्ड करना पड़ेगा इनिशियली, कि अच्छा ये पढ़ लिया, ये समझ लिया, अब वी लुक फॉरवर्ड टू थिंग्स व्हेन दे विल कम. फॉर एग्जांपल डिफरेंशियल इक्वेशन, उसका डायरेक्ट एप्लीकेशन है. तुम देखो कि बिना डिफरेंशियल इक्वेशन के ना तुम श्रोडिंजर्स कर पा रहे हो, ना तुम न्यूटन्स लॉ ऑफ मोशन कर पा रहे हो. मतलब उसका थोड़ा सा स्प्रेड थ्रू आउट है. तो कॉम्प्लेक्स धीरे 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 करके तुम देखोगे कि जब बहुत आगे जाओगे तब जाके तुम्हें रियलाइज होगा, अच्छा ये तो ऐसे लग रहा है. तो अभी के लिए इसको थोड़ा मैथमेटिकली पढ़ के ही कंप्लीट करना पड़ेगा. ठीक है, अब मुझे बताओ इसमें सिंगुलैरिटी क्या है. पहले z इक्वल टू 0. नाउ फाइंड मी अ लॉरेंट सीरीज एक्सपेंशन अबाउट z इक्वल टू 0 एंड टेल मी व्हाट सॉर्ट ऑफ सिंगुलैरिटी इज दैट. ये जल्दी से करो, आई एम गिविंग यू 2 minutes. ट्राई टू डू दिस इन 2 minutes. चलो मैं कराता हूँ. ठीक है, सो हाउ वुड यू गो अबाउट इट. तुम क्या करो, इसको सिर्फ एक्सपैंड करो. ठीक है, तो साइन z क्या होता है देखो, z माइनस z क्यूब अपॉन 3 फैक्टोरियल प्लस z की पावर 5 अपॉन 5 फैक्टोरियल माइनस z की पावर 7 अपॉन 7 फैक्टोरियल पर आगे बढ़ाते जाओ. ठीक है, डिवाइडेड बाय z क्यूब. सो दिस इज योर फंक्शन series representation. So what you'll find, you'll simply find z gets cancelled with z. You have 1 upon 3 factorial. Then you have all the terms. I think minus 5 on 5 factorial. देन यू हैव प्लस z रेज टू पावर 4 अपॉन 7 फैक्टोरियल। और अब तुम देखोगे कि सारे टर्म रेगुलर ही हैं, देयर इज नो प्रिंसिपल पार्ट। इफ देयर इज नो प्रिंसिपल पार्ट, in fact there is no principal part, दिख रहा है? अगर कोई प्रिंसिपल पार्ट है ही नहीं, इसका मतलब क्या हुआ? z इक्वल टू 0 कैसे सिंगुलरिटी हुई?
रिमूवेबल।
रिमूवेबल सिंगुलरिटी। ओके, बढ़े आगे। ठीक है, ट्राई टू डू दिस क्वेश्चन देन। आई थिंक वुड यू बी एबल टू डू इट? लेट्स से एक एक करो, चलो। 1/z+1 इंटू z+2। एक काम करो, z इक्वल टू -2 के अबाउट करो। Write a Laurent series expansion about z equal to -2. Z equal to -2, you can clearly see that this is a singularity. Yes or no? Now try to write Laurent series expansion and also see uh, कि क्या कह सकते हैं, किस टाइप की सिंगुलरिटी है z इक्वल टू -2। अभी के लिए सामने दिख रहा है z इक्वल टू -2 इज अ सिंपल पोल। तो आप लोरेंट सीरीज में क्या एक्सपेक्ट कर सकते हो? यू कैन एक्सपेक्ट दैट देयर इज ओनली अ वन प्रिंसिपल पार्ट टर्म containing z+2. So in principal part term, you will have only one term which will be of form 1 upon z+2. Okay, so that you have to do. So you have to write a Laurent series expansion of z equal to -2. How would you do that? So you simply write z+2 as u. Okay, that would reduce your problem. So you'll do this as u. Okay, and what is z+1 then? So z+1 will become u-1. ठीक है, यहां तक समझ में आई बात? अब तुम कहोगे इसके आगे करें तो करें क्या? तो व्हाट यू कैन डू, यू कैन जस्ट राइट इट एज u-1। जो न्यूमरेटर है ना उसको ऐसे लिख दो, u-1। ओके, अच्छा एक काम कर सकते हैं, इसको यहाँ नहीं भी लिख, इसके बिना भी कर सकते हैं, इसमें कोई दिक्कत नहीं थी। चलो कोई बात नहीं, तो ये हो जाएगा। कैसे लिख सकते हैं? देखो, 1 को नहीं लिख सकते u-1 ऊपर वाले को?
वही पार्शियल फ्रैक्शंस बना के वही अलग
पार्शियल
अलग
फ्रैक्शन
करके
बना के
शायद।
लिखो चाहे ऐसे लिखो, मतलब 1 को लिख दो u-1, तो लाइफ इजी हो जाएगी। तो 1/u आ गया यहाँ पे, एंड देन देयर विल बी, आई थिंक 1 अपॉन, सॉरी माइनस में आएगा, -1 अपॉन, अच्छा सॉरी यहाँ पे आएगा u-1, है ना? 1/u-1 एंड -1/u। ठीक है, कोई दिक्कत इसके अंदर? आया ना? जल्दी जल्दी जवाब दो, अपने पास टाइम कम है। हो जाएगा -1/u प्लस, इसको एक काम करो, 1 - u⁻1 लिख दो, ये वाले को तो, और एक नेगेटिव आगे लगा दो। समझ रहे हो? मतलब ये u-1 लिखा है ना, इसको लिख दो 1 - u⁻1। ये पूरी चीज तो बाइनोमियल सीरीज बन जाएगी। ये बाइनोमियल सीरीज कैसी होगी? देखो, 1 + u + u² अपॉन 2 फैक्टोरियल प्लस u³ अपॉन 3 फैक्टोरियल, सॉरी बार बार ये लिख रहा हूँ, 1 + u + u² + u⁴ कर लेना, ये चीज तुम्हें पता लग जाएगी। 1 + u + u² ये ऐसी आती है, 1 - x⁻1 प्रोवाइडेड मॉड u इज लेस। ठीक है, लेकिन ये वाली जो चीज है, ये वाली चीज क्या देगी तुम्हें? -1/u। -1/u मतलब -1/z+2। यहां तुम्हें दिख रही है कि सारे टर्म्स कैसे बन रहे हैं? सारे टर्म्स ऐसे आ रहे हैं, कैसे आ रहे हैं सारे टर्म्स? दीज आर ऑल द टर्म्स विच आर in the regular side, that is these are all z+2 की पावर 1, z+2 की पावर 2, z+2 की पावर 3, z+2 की पावर 4। how many principal part term are there? Only one principal part term is there. Since there is only one principal part term, so that would imply me what? That would imply that z equals to -2 is a simple pole. Yes or no?
यस सर।
यस।
चलो एक क्वेश्चन करो अपने होमवर्क के लिए, दो दे रहा हूं मैं तुम्हें। z एक ले लो इधर, और यहाँ कर दो z-1 इंटू z माइनस, सॉरी z+1 इंटू z+2। ट्राई करना इसको घर पे, ये सेम एट z इक्वल टू -2। ठीक है, तो कल एक क्लास और ले लेते हैं लोरेंट सीरीज की, और इसको खत्म कर। आई होप इट इज क्लियर।
हाँ भैया।
यस सर।
अभी जाने वाला टाइम, हम बोल दो तुम एक बार क्या कह रहे हो।
ठीक है। ये फिर है ना ऊपर वाले क्वेश्चन में z+1 के अराउंड भी सेम इसी तरीके से निकलेगी ना?
सेम 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 सेम।
सेम वही तरीके से
सेम
तो
वही तरीके
ना